Now, I didn't have a chance to look at the mark scheme for number 9 on the last video, so let's just double check that we got things correct. Here's our value of W, right? 1.3 times 10 to the negative 3, and we thought that statements 2 and 4 are the only false ones. And on the mark scheme, it tells us that we are correct, 1.3 times 10 to the negative 3, and so you'll get 2 marks if you were able to first evaluate what the multiplication of these two scientific notation numbers was, and then another mark for moving the decimal to after the 1, and another mark for having the correct 10 to the power of negative 3. And you'll see that its statements 2 and 4 are incorrect. Each one is worth 2 marks. You can't get partial credit for either of them. If, for some reason, 2 and 4 were given and then the student circled one other one, well then you would have at least been allowed to get 2 points total out of 4 on 9b. Let's work on number 10 now. We've got a couple of scientific notation numbers of m and n, and we need to figure out first what m times n is and then what m divided by n is, and we should write our answers in scientific notation. So I'll use the calculator to do this. Okay, in part A, I'm taking my m, which is 6.0, and I'm multiplying it by 10 to the power of 3. And then I'm taking that result and I'm multiplying it by 2.4 times 10 to the power of negative 5. And I get an answer of 0.144. But I need to express it in scientific notation. So that means moving the decimal point to immediately after the first non-zero digit. This is the first non-zero digit, that 1. So I've moved the decimal to its new location. So it's times 10 to the power of, well, I only moved it 1 spot, didn't I? So 10 to the power of 1. But because this is a small number, that is less than 1, it must be a negative exponent. Part B, m divided by n. So we've now got 6.0 times 10 to the power of 3, which is now being divided by, I better put this second expression into parentheses to illustrate that it is the, in fact I probably should have done the same thing to the numerator. Yeah, let's go back. And I want to insert a parentheses around the entire numerator as well to make sure that the whole thing is treated as a single value. So we're just going to, what's it done? Let's try that again. So I've inserted a parentheses just before the 6, and I want to insert a parentheses just before the divided sign. And so I'll say second, delete to insert a parentheses there. Alright, now I can move on to the denominator, which has got a 2.4 times 10 to the power of negative 5. Close the parentheses, because, well, maybe I should do it there. Alright, ready to divide. Wow, that's a big number. 2, 5, and then I count 7 zeros. 2, 5, and then 7 zeros. Now, in order to put this into scientific notation for my final answer, you'll notice that my first non-zero digit is the 2. So the decimal point will go straight after the 2. And it's not necessary now for me to include all of the zeros after that 5. For me to say 2.5 represents the exact same quantity as 2.500000000. So we don't need all of those zeros at the end in this situation. And it's times 10 to the power of what? How many times did I move the decimal? Let's see, it ended up here, it started here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8 times. And because this is a very large number, then it is to the power of positive 8. So we'll just check our solutions here. We're expecting 1.44 times 10 to the negative 1 and 2.5 times 10 to the power of 8. And that is exactly what we got. 1 mark for the method of multiplying them and 1 mark for the answer. Again, 1 mark for the method of multiplying them and 1 mark for the answer. On to number 11. We have a rectangle with its given length and width. we first need to find the area. Well, we know that area is length times width, which is going to be 2.6 times 10 to the 4 times our width of 1.9 times 10 to the 4. The order in which you multiply numbers together doesn't matter, so we actually won't need any parentheses here. If you're going to feel nervous about that, feel free to add parentheses in your calculation so that you can feel more confident. Anyway, I'm just going to do this without parentheses because I know that the order in which we multiply things won't change the result. And that's multiplying 1.9 times 10 to the power of 4. And I got a big number, 494, with 6 zeros. And they want us to express it in scientific notation. And so we'll move the decimal point to immediately after the first non-zero decimal point, which is the 4. And I don't need to have all of those zeros at the end of the number anymore. And how many times I move the decimal point? 1, 2, 3, 4, 5, 6. Oh, I miscounted. 1, 2, 3, 4, 5, 6, 7, 8 times. And so that's going to be times 10 to the power of, and it's a positive 8 because we're dealing with a very large number here. The perimeter is calculated by taking 2 lengths plus 2 widths. And so let's do this on the calculator. So we've got 2 times 2.6, 2 times 10 to the power of 4. And to this we need to add 2 widths. So that's 2 times the width of 1.9 times 10 to the power of 4. Again, I've gotten away without using parentheses here because I know the order of operations demands that I'm going to do these multiplications first. And so I will figure out this quantity, the total of the 2 lengths that are opposite each other of the rectangle, and the total of the 2 widths, yielding me a total amount. And so parentheses not necessary. I've got 90,000. And if I express this in scientific notation, it will be 9.0000. Well, there's no point putting any of those. And if this is the new location of the decimal point, then the decimal moved 4 times, and it's a positive 4 because 90,000 is a large number. So let's just check our answers. 4.94 times 10 to the 8, and 9 times 10 to the 4. And there we go. And yeah, same thing. It's amazing that they can give 4 marks for something so short, but they've given a method mark for knowing that we should substitute in the scientific notation numbers, and then an answer mark for accurately substituting them, and then 1 mark for the 4.94, 1 mark for the 10 to the power of 8. In the second one, again, 1 method mark for demonstrating how we've substituted into the perimeter. Now, I actually didn't do that in my solution, but IB does tend to give marks out, even if you have missed a method, as long as your answer that follows is correct. If I were you, I would be safe and always include the method, and I should have included my substitution on this one like I did in part A. And they'll take 9.0 times 10 to the 4, or as I gave it, simply 9 times 10 to the power of 4. Number 12. Anthony's got this formula of 27Q over R plus S, so let's substitute in his values of R, Q, and S, and see if we can figure out the value of P. So P is going to be 27 times the Q value, which is 0.89, and we're going to take that result and divide it by the sum of R and S, which are respectively 1.87 and 7.22. Now, before you put things into your calculator, think very carefully about what we're going to do here. We want to divide by the entire sum. And so put your denominator into parentheses. Here we go. 27 is multiplying 0.89. And let's figure out what that result is. And now we will divide that result by the sum of 1.87 and 7.22. And now it will give us the answer of 2.6435 and so on. You know what I've just realized? I've just done part B, haven't I? I used a calculator to work out the actual value of P. And so P we found was 2.64356435, and so on. To what degree of accuracy would we give our calculator answer? Remember that the standard, if not sort of otherwise specified, is always to 3 significant figures. And another justification, you could say, is that we round to 2 decimal places, which actually ends up being the same answer. Why? Well, because the question was given to you with 2 decimal places. Let me come back, though, to part A, because I didn't read the instructions very carefully. I did it with a calculator first, so let's do it now without. We're supposed to write down the numbers Anthony could use in the formula to estimate the value of P. So what's a number pretty close to Q? Yeah, it looks to be Q is nearly 1. R looks to be almost 2. S looks to be a little bit higher than 7, but let's round them to these integer values. It'll be easier to deal with. And so then those are our estimates. Q is approximately 1, R is approximately 2, S is approximately 7. And what is the value of P going to be if I use these values? 27 times our estimated value of Q divided by the sum of R and S. And so I don't really even need a calculator for this, do I? That's 27 over 9, which equals 3. And, well, that's the end of the question. I'll just do number 13, and then we'll look at the answers to 12 and 13 together. We've done one of these already, haven't we? So we're just going to do a division between 6.4 times 10 to the power of 7, and we'll divide it by the product of 1.6 times 10 to the power of 8. And make sure you put the denominator into parentheses so that we are dividing by the entire thing. Now this is what I was saying before, that we should really show the substitution into the expression on paper, just so that we could get a method mark or two, so that if something went wrong on the calculator, we can still get part marks. I'm betting that a lot of you might forget to put parentheses around the denominator, and so you'll end up getting a wrong answer. Well, at least write down the substitution method step so that you can get partial credit. Okay, we get an answer of 0.4. Done. The question doesn't tell us. Oh, yes, it does. Give your answers in the form scientific notation. And so we'll move the decimal point immediately after the first non-zero digit. I don't need to put any zeros afterwards, because that's, of course, representing the same quantity. And I moved it 1 place, and because this is a small number, it's to the power of -1. And part B, we're taking the y value of 1.6 times 10 to the power of 8, and we are subtracting the product of 2x, so 2 times the x value, which is 6.4 times 10 to the power of 7. And that gives us an answer of 3, 2, and then 6 zeros. I should have written my substitution step. So that's 1.6 times 10 to the 8 minus 2 times 6.4 times 10 to the 7. That's my 2 x's. Gives us 32 with 6 zeros, and we're supposed to write that into scientific notation. My first non-zero digit is 3, so the decimal point will come straight after that. How many times did I have to move the decimal? 1, 2, 3, 4, 5, 6, 7. And because it's a very big number, it's a positive 7. So let's just quickly check our answers to number 12 and 13. So number 12, we got Q is 1, R is 2, S is 7, and P is 3. And in the answers, that's exactly what it says. P is 3, Q is 1, R is 2, S is 7. So 1 mark for your 3 estimates, 1 mark for your estimate of P. And part B, either 2 decimal places or 3 significant figures. And, I didn't write down my reason. I would have lost a mark. This one gave a reason, because 2 decimal places is given. I mentioned that, but I didn't write it down, and that's my fault. And number 13, It's got the answers of 4 times 10 to the power negative 1. You'll see that there's a method mark for the substitution and then another method mark which would be optional, but there's your answer marks, and 3.2 times 10 to the 7. Same thing as we got to. And that brings us to the end.